Ismail is here. Today we're going to start the lesson 5.1 trigonometric identities. In this lesson we are going to focus on how we can simplifying trigonometric, how we can identify the basic one and to find the trigonometric values, then use the basic trigonometric identity to simplify and rewrite the expression. Okay, now let's start with the first thing here, the basic trigonometric identity. Now we know that any equation, okay, considered as identity means this one here, it's a normal equation, right? So we call this one as identity. Now if you look here, trigonometric identities, what's the meaning of trigonometric identities? If we read here, trigonometric identities are identity that involve trigonometric function. So we understand if this is a normal identity with normal variables, if I have sine, cosine or tangent, that any of the trigonometric, so we call them now trigonometric identity. So this is the difference between the normal identity and the trigonometric identity. Now let's focus here on the reciprocal identities. As we can see here, we have the reciprocal and quotient identity. We have two types of identity. The first one, which is the sine identity, and the reciprocal for sine is 1 over cosecant. Now cosecant is reciprocal for sine, which is 1 over sine. Now for the cosine, cosine is 1 over secant, and secant is 1 over cosine, which is the reciprocal. Then the last one is the tangent. Tangent is 1 over cotangent, and cotangent is 1 over tangent. So those are the reciprocal. Now the quotient identities, okay, so those are the reciprocal and those are the quotient identities. Quotient identities are the tangent and the cotangent. We know that tangent can be written as sine over cosine, and cotangent can be written also as cosine as sine, which is just flip. Here it's sine over cosine, here cosine over sine. So it's just a flip between them, then you can. You have to memorize or to understand these identities. Means because you are going to pick any of them while you're simplifying the question. Okay? Now let's take one example here. Look to this example here. Use the reciprocal and quotient identity. Focus on the first question here. If cosecant theta is equal 7 over 4. So what is sine theta? I know that cosecant is reciprocal for the sine, right? So we can just write directly it's 4 over 7. Or use the rule. You know that the rule is from the previous, sine is equal 1 over cosecant. Let's go back here. See? Sine is equal 1 over cosecant. So now I have cosecant is given. Cosecant is given as cosecant is given as 7 over 4. So I need to replace now 7 cosecant with 7 over 4. So now 1 over 7 over 4. So what's happened here? This 4 goes in the numerator, so it becomes 4 over 7. Or you can just write it like that. But I just showed you how you can use the formula or the reciprocal formula. Now let's go here. As you can see, if cotangent theta is equal 2 over 5 square root of 5, and sine x theta is equal square root of 5 over 3. Now find cosine theta. Now when you need to solve the question, we have reciprocal rule and we have quotient identity. So you need to pick which one can fit with the question, and I will help you or give you a hint. So the hint, okay, always, okay, it's not hint, but always will help you to solve it. Use the given information. What's the given for trigonometry? The given is cotangent, okay, which is equal to 2 over 5 square root of 5, and sine x also is given, which is equal square root of 5 over 3. So cotangent and sine are given. So if you go back here to the reciprocal, which formula from all of this, okay, the reciprocal or the quotient should has sine, okay, and it should has cotangent x. So as you can see here in this formula here, cotangent is written here and sine also is written here. I can find cosine from this formula. So now let's use this formula. So the formula is cotangent x is equal cosine x over sine x. Now substitute everything. 2 over 5 square root of 5, this is for cotangent, and I need to find cosine x over sine, which is equal square root of 5 over 3. Now let's find cosine. So you can use cross multiplying cosine times this. Okay, don't forget this is whole one fraction, right? And this whole fraction multiplied with 2. Now cosine times 5x, so cosine x 5 square root of 5 times cosine x equal 2 times square root of 5 over 3. Now we know that if I have a fraction times a number, so a number times a fraction, what we do, we just multiply the numerator with the number, that's it. So we multiply 2 with the square root of 5. So now let's write the question, 5 square root of 5 cosine x equal 2 square root of 5 over 3. Now I need to isolate cosine x. So what should I do? I need to divide both sides by cos 5 square root of 5. So 5 square root of 5, so these are cancelled, and all of that also is 5 square root of 5. Okay, now because the fraction in the numerator, so this one goes down multiplied with the 5. So now let's write here, so cosine x is equal to square root of 5 over, because now 3 times 5 is equal 15 square root of 5. Can I simplify things? Yes, I can simplify square root of 5 with the square root of 5. So I can extract that cosine x is equal to over 50. So this is the final answer. I hope you understand this. Now try by yourself to solve this equation, and if you need any help, please let me know. Okay, now let's go to the second part here. The Pythagorean identity. After we finish from reciprocal and identity, now we have the Pythagorean identity. And as you can see the Pythagorean identity, let me just explain it to you what is or how they get the Pythagorean identity. Now, let's do it here. Okay? So let's say I have the y and x axis. From what we studied from chapter 4, if I have a point here, this point has x and y, right? So if I need to draw a triangle using this one, using this point, I can draw the triangle using this one here. I know that the line below here represents x, and the line here represents y, and the hypotenuse represents r. So now if I need to form a formula, I can form that r squared equal x squared plus y squared, which is the Pythagorean identity. Now, if you remember, I told you also, because if you use the unit circle, x represent what trigonometry? X represent cosine, if you remember. Cosine x is represented by x, and y represented by what? By sine x. Now if I replace x and y, so x is cosine, y is sine. So if I replace x with cosine squared x plus y, replace it with the sine squared x, remains to me r squared. I told you from the previous, r is always equal what? 1, because of the unit circle. So I can just replace r with equal 1. So the formula remains x squared x plus sine squared x. So this one is the formula from where we did we get this one here. So sine squared x theta plus cosine squared x cosine squared theta equal 1. So this one here. Now, how can I get these other formula? You can just extract this formula better than just memorizing. Okay, if you are, let's say, solve many questions, your brain automatically will memorize the formula. But let's say you didn't practice a lot, or you have a slow brain memorizing. So what you have to do, try to understand how to get these formula from the original one. If you can just memorize the first one, and you can, from the first one, you can extract the second one and the third one. How you can extract number 2 and how you can extract number 3 formula. So from using the first formula, sine squared plus cosine squared equal 1, if you divide everyone by cosine squared, so cosine squared, divide everything by cosine squared, divide everything by cosine squared theta. You can know that sine squared over cosine squared, this one is the quotient identity. Sine over cosine means what? Equal tan squared. Now cosine squared over cosine squared is equal 1. Now 1 over cosine, this is the reciprocal identity. Reciprocal 1 over cosine is secant square. So now if you divide everything by cosine, you will get the formula number 2. So this one, if we divide everything by cosine square, we can get this formula. Here, if we divide everything by sine squared, okay, we will get this formula, which is cotangent over cotangent squared plus 1 equal cosecant squared plus cosecant square theta. Okay, now don't forget this formula, it's not only in this way, because the question, you are a pre-calculus student, the equation, it's not always represented by this one here or this one here or this one here. Means you can simplify and solve the formula in terms of something, which means, for example, let's take the first one here. If I need to find sine from this formula, I can solve this formula in terms of sine, which means I can minus cosine square theta minus cosine square theta from both sides. So I cancel this and this. So sine squared theta is equal 1 minus cosine squared theta. Same thing, if I need to find or solve in terms of sine theta, so I can do the same thing, which is minus sine squared theta minus sine squared theta. So now I can cancel sine with sine, so remain for me cosine squared theta equal 1 minus sine squared theta. Okay, I hope you understand this. Now, the same thing happened with the second one. If I need now to find in terms of tan, so I can minus 1 from both sides, so it's equal tan squared theta equal secant squared theta minus 1. Okay, now for the third one also the same thing, minus 1, so it will be cotangent squared theta equal cosecant squared theta minus 1. Okay, so you can use all. Now as you can see, we have many formulas, so all of these formulas you need to understand them and you can use one of them. Okay, but before we go next, don't mix. If you look to this formula, it's written 1 minus cosine squared theta, right? If the question written as cosine squared theta minus 1, this one here, it's not same. They are not same. They are not same. They are not equal. Okay? So because here cosine, if you look to this one, cosine is negative. But here cosine is what? Cosine is positive. Here number 1 is positive. But here number 1 is what? Is negative. So this one not represented by this one. Okay, so don't tell me this one means equal sine squared theta. This is wrong. Don't do that. But this one here is equal sine squared theta because 1 minus cosine. Okay, don't mix between them. They are not equal. Okay, same thing for all the formula. Okay, now let's start solve the first one. Use Pythagorean identities. So the Pythagorean identity, the first one here, tan is given. Tan theta is equal negative 8. And it's mentioning to me that sine is greater than 0, which is positive. Okay, positive values. So we need to find sine and we need to find cosine. Now let's start solve this question. Now, always we have, don't forget, we have reciprocal identity and we have quotient identity, and the last one we have Pythagorean identity. Reciprocal 1 over something. Quotient is the tan or the cotangent, which is equal sine over cosine, or cotangent is cosine over sine, and Pythagorean identity, which is what we studied now, sine squared plus cosine squared equal 1, or the other formula. Okay, so we need to use all of these formula now to find the question, to find sine. And always, I just give you a hint. Always try to start with the Pythagorean identity. If you start with the Pythagorean identity, you can next after that you can use the quotient or you can use the reciprocal. So let's start with the Pythagorean identity first. Now I have tan is given. Okay, I need to find sine and cosine. Okay, which identity that can help me to find cosine or sine? If we go back here to the identity, I have tan identity can give me is 1 plus 1 secant squared, okay, which is secant. I know that secant is the reciprocal for what? Is reciprocal for cosine. So if I use this one, I can find what? I can find cosine. And if I find cosine, I can find sine using the quotient identity. Okay, let's do it. Let's see how we can do it. So the first thing, tan square theta plus 1 equal secant square theta. So now tan is equal negative 8 square plus 1 equal secant square theta. So it equals 64 plus 1 equals secant square theta, which is equal 65 equals secant square theta. Now to remove the square, I need to use square root for both sides, square root. So square with a square root remains secant theta is equal positive or negative square root of 65. So from this one here, I can know that because it's reciprocal, okay? So it's equal to me right here. So cosine theta is equal 1 over square root of 65, which is because I can't have a denominator square root. So let's multiply square root 65 here, square root of 65 here. So now if you need to simplify this, so cosine theta is equal square root of 65 over 65. So this is the answer. So now I have tangent given, I have cosine given. Can I find sine? Yes, I can find sine using the identity. So tan theta is equal sine theta over cosine theta. So tan theta is negative 8 equal cosine theta is square root of 65 over 65. I need to find what? I need to find sine theta. Now what should I do? I know this is only one term. So now let's use cross multiplying. This is over 1. So all of that times negative 8 and sine times 1. So now it will be sine theta times 1 is sine theta equal negative 8 times square root of 65 over 65. If you remember, when I have denominator is fraction times a number, we multiply this with the numerator only. So it's equal negative 8 square root of 65 over 65. Can I, so sine theta is equal this. Can I simplify this? No, I can't simplify this because 8 divides 65, it cannot be simplified, which is we get a fraction. So this one is the final answer. So I have cosine and I have sine. So done and done. Okay. Now let's solve the second one here. So let's do this. Cotangent theta is equal to, okay, and it's giving me that cosine is negative. Oh, sorry, I forget. Let's go back here. Sorry. The question here, it's telling me that sine, it should be positive, but sine here is negative. So what should I do? The thing that you have to do, just remove the sign. Okay, just write positive. That's it, done. Don't bother yourself with the steps, how we can do to the steps. No. Just when you find the answer, okay, and the answer here, look to the given here, positive or negative. So just remove the positive or put the negative, depend on the question. Now let's do the second one and see what we can do. Now for the second one here, cosine is negative. So as you can see here, now we need cosine to be as negative. We need to find sine and we need to find cosine. Now, as you can see, I can use the rule that has cotangent. Cotangent, okay, it has, let's go back here, cotangent, it has cosecant. And I know that cosecant is reciprocal for what? For sine. So I can find cotangent and sine from the first step. So let's do it. So cotangent square theta plus 1 equal cosecant square theta. So cotangent is given is equal to square plus 1 equal cosecant square theta, which is equal 4 plus 1 equal cosecant square theta. So 5 equal cosecant square theta. So now if we use a square root for both sides, we will get that cosecant theta is equal square root of 5, positive or negative. Okay. Now from the cosecant, I can find sine. So sine theta is equal 1 over square root of 5. Now I have to multiply both sides by square root of 5, square root of 5. The final answer will be sine theta is equal square root of 5 over We're done. We found sine. Now let's find cosine. So we use the same quotient rule, which is cotangent theta, because cotangent is given. Okay, is equal cosine theta over sine theta. Now cotangent is given, which is equal cosine theta over sine. Sine is square root of 5 over 5. So now we cross multiply this over 1, cosine times 1, and 2 times this. So it will be cosine theta is equal to square root of 5 over 5. Now this is the final answer. But as you can see, as I told you, cosine is what? Cosine is negative. So I have to put negative in the final answer. Okay? I hope you understand this. This is easy. Try now to solve these two questions by yourself. And if you need any help, okay, please ask me. This is the answer. Okay? You can stop and continue.